quantum mechanics cannot be forgotten because there is a lot of experimental evidence to the effect of giving us quantum mechanics outcomes and results and particles and these discoveries that keep happening, including but not limited to, of course, the Higgs boson in 2012, and before that so many other particles, right? Proton, neutron, quarks, all of those particles being discovered, giving sort of confirmation and validation and further and further and further proof that quantum mechanics is good. Quantum mechanics is something bizarre, but it does give us all these results that are experimentally proven. So quantum mechanics didn't go away. That's the thing. There were bizarre developments happening to the effect of people discovering quantum mechanics and further making more and more discoveries under that topic. And general relativity cannot explain quantum mechanics. And so general relativity is considered more of a classical theory, whereas quantum mechanics is, for say, quantum theory, quantum versus classical, right? This classical versus quantum battle is still a thing. It was very much a thing. People did not like quantum mechanics from the classical camp. And their theory, though, could not explain some of the things that were coming out of quantum mechanics. And because of the evidence and because of the experimental successes of quantum mechanics, they could not ignore it either. So they wanted a theory of everything. They wanted a grand unified theory, or a GUT, a theory of everything. You might have heard of that term. And a candidate for that, once again, is string theory. This is the motivation for string theory, so we cannot completely ignore it. But long story short, once again, I think I titled the live stream as "Is String Theory Wrong?" The answer is we don't know. As far as I know, the answer is that we don't know. We don't know if string theory is wrong. We don't know if string theory is right, because a string theory is so far not testable. But I wanted to tell you all of these words above because this is what's going on. This is the motivation. We want a theory of everything. A candidate for that is string theory. Is string theory right? We don't know. Is string theory wrong? We don't know. Is string theory testable? So far, no. Okay? So that's what's going on. We will learn a lot more details going forward in this live from the book, directly from a string theory author, Brian Greene, Greene with the extra E at the end. Brian spelled normally like the B-R-I-A-N, Brian Greene, who wrote The Elegant Universe, Superstrings, Hidden Dimensions, and the Quest for the Ultimate Theory. So this quest for the ultimate theory is what motivated the work in string theory. Hello, Jay. And this quest for the ultimate theory is why people stomached these sort of extra dimensions, hidden dimensions, and sort of the more stranger quirks of string theory. Because those dimensions, having the extra dimensions was allowed by general relativity, it's almost like, because you might say, well, what is so bizarre about quantum mechanics? Depending on who you are, you'll either find string theory very bizarre, or you'll find quantum mechanics very bizarre. The classical theorists or the classical physicists found quantum mechanics to be very bizarre. Quantum mechanics and its uncertain nature, its probabilistic nature, finding a ton of particles all the time, discovering more and more particles without an overall explanation of what it all meant. Those people thought quantum mechanics was bizarre. Quantum mechanics people probably think that string theory is bizarre because string theory has all these extra dimensions and makes it impossible to test. So it's basically a point of view that we must be aware of. We must educate ourselves to know, like, everybody is a little bit biased. Everybody comes from their own points of view. And so when you are being taught physics and when you're being, when you read the news or you hear some announcement or you learn some piece of information, always kind of keep in your mind what the source is and what they're trying to say and what sorts of contexts and points of view they might be coming from. So classical physicists think that quantum mechanics is kind of weird, and quantum mechanics people think that classical physics is kind of weird, especially when you talk about string theory, having all these extra dimensions. Classical mechanics, the stuff we need to understand gravitation, the planetary motions, the laws of motion, and the moon orbiting the earth and the earth orbiting the sun, that stuff is not so weird. That is just Newtonian mechanics. It's been well understood for centuries. But once Einstein gave us deeper insight into gravitation,